In 15 seconds, a lot can happen. A race car at top speed can travel almost a mile. Your heart beats about 20 times, and you can scroll through 2 to 3 Instagram posts. And an FRC robot can score multiplied points all on its own, using pre-programmed instructions. Every year, Auto accounts for nearly 1/3 of the points scored by all robots across the season. It's one of the most challenging and rewarding aspects of the first robotics competition. Kicking off our season 2 of First Rewind, we're covering the history of autonomous, how it started, its evolution across the years, and where we think auto mode is headed.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Support Fun's content creators when you sign up for a membership on YouTube Join. You'll get access to special perks like emotes, loyalty badges, and Fun members will even get early access to our scheduled videos and more. 100% of this revenue will go back to our correspondents to help recognize their efforts. Click the join button in any YouTube video to pledge your support.
Hi, I'm Ari, a mentor on Mojo Team 8085 and your guide through history.
And I'm Nick. I am a programming alumni of FRC Team 2358 Robotics.
Thanks, Nick. So let's start off. How does having an autonomous period impact FRC?
I think one of the biggest things is the impact on strategy, particularly with teams when they start their seasons. One thing that a lot of teams do is they think about what can we do in the autonomous period. It's 15 seconds. Time is always the enemy in FRC and first in general, but especially in an auto. So it's talking about what can we get done in those 15 seconds? How much time do we need to budget out of our build season to plausibly get those autos? And also, what do we want to prioritize strategically? Then further emphasizing the strategy, once you get to events, you need to start talking about what your autos can do and what other teams' autos can do so that you have the best autos possible, both in qualifications where you're randomly decided and don't know who you're paired with, and in eliminations so that you can pick compatible robots.
Absolutely. I think strategic design too is completely impacted by what you design your robot around and what you want to do in that 15 seconds. So optimizing kind of your mechanical side for your programming side is one of the most interesting things that I think FRC presents as the autonomous mode. I mean, some really specific robots really capitalize on those things. 254 in 2014, Cheesy Poofs with aerial assist really designed their robot around that autonomous period. They were able to grab all 3 of those big exercise balls and score them in the autonomous period. And I think that was a really cool design choice. What do you think about like the technical challenge of the autonomous period, Nick?
Yeah, on that, I also find it very interesting. Personally, I was a programmer myself. I did write some autonomous code in my time as well. That was, to me, it was one of the most fascinating aspects of programming in First. Because not only are you programming the robot to function, you're also programming it to be able to literally drive itself. Now, it's a controlled autonomy because you're in a controlled environment, but that's still an application you don't really see in most of the things you do as a high school programmer. So to me, it's just incredibly fascinating for that regard.
Absolutely. There's a few different levels of autonomous too, so I think really seeing what you can do in autonomous and programming the robot is a very different thing. Autonomous mode debuted in the 2003 game Stack Attack as the first period of robot movement in the match. Matches in 2003 were divided into 3 periods: human player movement, autonomous control, and operator control. There were almost no options for plug-and-play sensors at this point, and mostly robots ended up just moving across the field or doing nothing during this period. Few teams made use of line tracking available on the field, opting instead to de-score human-created stacks or climb up the ramp in the middle of the field. 111 Wild Stang dominated these early auto modes with adaptable waypoint pathing in a program called Stang Sense. Between this pathing and an early iteration of Swerve Drive, they were the only team in 2003 to knock over the human play stacks and get to the top of the ramp in 15 seconds, sporting systems that would take decades to become widely available. First continued the autonomous period into 2004. with the introduction of the starting line and the all too familiar phrase, drivers behind the line. 2004 also saw the introduction of the infrared beacon and IR sensors, and more teams began to capitalize on smarter programs. Teams could pick up a bonus ball in auto, releasing game pieces onto the field for earlier collection. Early autos were limited to straightforward auto-specific tasks. Even teams with top-tier programming could only run about 6 variations on auto, with 15 steps or less in each, much different from the level of complexity we see today. How has auto evolved since you first got involved with FRC?
So, admittedly, I am comparatively new to FRC. I was a 2020 rookie, so this was now my 5th season involved. So, some things that are relatively new, such as Limelight, had already developed and become widespread. Um, However, that doesn't mean there aren't things that haven't developed. For example, we've seen Swerve Drive go from not uncommon to feeling like an insane number of teams have it, given that it's become much more accessible now that there's, I think, at least 3 or 4 different companies selling commercial off-the-shelf modules. There's a bunch of open source code and support for teams to adopt it, so it's become much more common, and as such has had applications to the autonomous period, given the many ways that you can also use it to uniquely control your robot under its own motion. For example, what we've seen over the past couple years is the rise of things like Path Planner, where teams can just say, I want to be here, 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 and I want to point this way, this way, this way, and this way, and then a computer program just spits out a thing, and then the robot just does it pretty well. So I think probably the biggest development since I got involved was that development of Swerve Drive and Path Planner. But that's not to say that there aren't other things. For example, Vision and A-Stop are both huge. Vision shifted from retroreflective tape vision, which was mature and developed by the time I got involved. But then by 2023, we started seeing tags come in, which led to a complete new setup for vision and autonomy. And also with A-Stop, we saw that massively change autonomous strategy this year, both in terms of lowering the floor, where plenty of teams could get an auto, because now instead of needing to make sure the robot stopped on time, they could hit the A-Stop when they were ready. And also with the strategy of racing out to the midline and knowing that if you're about to pull a penalty, you can smack the A-Stop and just abort to avoid it. All of those things are things that have really developed in the relatively short time I've been in first, but that doesn't make them any less massively consequential.
Absolutely. I think the A-Stop was not just an innovation in this year's game, but an innovation through all of first. And I think that we're going to see a lot of really great things happening because of the A-Stop. Now you don't have to disable your robot just because one thing went wrong in auto. Now it's, yeah, this didn't go well in auto, but we can still play the rest of the match. So A-Stop has been crazy good for all of us. I think that one of the most important things that we've seen, even in the last few years, is the rise of advantage scope and data logging. I think that being able to really go back through the match and really see what you were doing in autonomous and also in the teleoperated mode and just logging that data has helped so much with the amount of troubleshooting and just information on mechanisms that we have that has just improved the entire program. But overall, in terms of how auto has evolved from when I got involved, there are a lot more teams actively participating in autonomous mode now. I saw my first autonomous mode in 2013. There were a lot of teams that did not move forward or did not shoot or anything. The video here shows the World Championships. It seems like a pretty high level, but we know we got even higher than that this year. And it's been exciting to see just the level of not only the floor, but the ceiling just rising so high over the last few years. And a lot of that's due to splines and waypoints and just overall the general controls of this program have gotten to such a high level that I'm very excited about. Kenan, you mentioned tag vision. What's your experience with that and waypoints in the autonomous period?
I don't have a ton of experience with that. My team did some experience with waypointing, mainly because in 2022 my team was a fender shooter, and they decided that they wanted to develop a 5-ball, which was cool. Except the one thing you may notice is that is a lot of driving to do in 15 seconds when you can't stop at the ring to shoot. So developing those waypoints and trying to nail them down so that robot could actually get where it was supposed to go um, in the time allotted was definitely a challenge that was we were there to see. A lot of time of driving back and forth in one of our school spaces that just happened to have carpet, just to test how that robot could even possibly work.
Well, that's pretty cool. Yeah, waypoints are definitely something that has improved over the course of just even a few years, and I'm excited to see where it goes in the future.
We hope you're enjoying this video here on Fun. If so, do make sure you click that subscribe button to stay up to date on all Fun YouTube videos and give the video a thumbs up. It really does help. We'd like to thank this show's sponsor, Kettering University, for their support of Fun. Those who are accepted in the Kettering University are eligible to receive up to $5,000 a year in a robotics scholarship. Head on over to kettering.edu/first to get more information about Kettering University and the robotics scholarship. Over 30% of those who attend Kettering University were in high school robotics, so go attend somewhere that has so many other people like you at kettering.edu/first.
The 2006 game Aim High saw the precursor to the auto modes that we see today. In the first 10 seconds of the match, teams had to play the game as they would in teleop mode, collecting, aligning, and scoring. And at the end of the period, the winning alliance was awarded a 10-point bonus. Variations on this theme would continue for most FRC games. Multipliers and bonuses would help incentivize more complex auto modes, along with the introduction of retroreflective markers on games. There would be a few outside-of-the-box autonomous periods in the next 2 decades. Most interestingly, 2012's Hybrid period and 2019's Sandstorm. The Hybrid period in 2012, Rebound Rumble, featured an innovative new way to control robot actions, using a supplied Xbox Kinect system. This didn't work out quite the way that first intended, and most teams continued to write pre-programmed instructions that read from sensors as before. The most change that Autonomous has seen since 2006 came in 2019, Destination Deep Space, when driver stations were covered by a curtain for the duration of the period. Drivers were allowed to operate controls during this period as they would during the match. This was mostly circumvented using a system of cameras, but some teams opted for autonomous portions of this 15 seconds, inspiring a new way of thinking. If autonomous pathing was faster, how could FRC teams use it in the teleoperated period? There have been many outside-the-box solutions to the autonomous challenge. What is the most interesting solution to auto that you have either seen or implemented?
I think one particularly interesting way we saw it was particularly some robots that were directly designed around or had some element of the robot that was expressly only for autonomous and only there for that purpose. One example would be arms on 2023 robots that were there just to place game pieces. For example, near me, I'm based in Illinois, so the team I'm most familiar with that did that is 1756 Argos. I know other teams did it too. There's the example I'm familiar with, where at the start of Autonomous, they had this arm that was holding a cone, and they would just flip it out, drop the cone, and then that arm would not be used again for the rest of the match because that was its sole purpose. I think that was probably the most interesting specific autonomous implementation I've seen in my time. But obviously, there's plenty of other stuff.
Yeah, I think going off of that, the little cube catapult on 118 last year in 2023, where literally in autonomous mode, they launch the cube up to the highest level and then drive back for their 3-piece. That was really fun. I love that that was literally only used for the autonomous period. My favorite thing that I've seen as an interesting solution to auto happened in 2014. And that was when vision tracking that year was basically that the goal, the outside of the goal, was illuminated with yellow LEDs. And this proved a bit hard to track using vision systems. So what teams ended up doing was using this program called Cheesy Vision. It was developed by 254, and what it ended up doing was it was a program on your computer. It read from your camera on the driver station, and drivers would highlight their hands in a box to highlight which goal was the multiplied points goal. So as you see on the screen, the white box is for whatever's going to be the kind of key, and wherever your hand ends up is going to be the hot goal. So that was a little silly, but it ended up working really well, and it ended up working a lot better than whatever goal tracking that teams used via camera systems. It was outlawed the next year. You weren't allowed to use any tracking that actively relied on the drivers and any other FRC game, but it was one of the most creative and innovative solutions that I have seen to the autonomous mode. Um, what other systems have you seen around that maybe not in the autonomous mode, but maybe use autonomy in an interesting way during the teleoperated match?
Yeah, one that particularly pops to mind is from 2023. That would be Team 4678 Cybercavs out of Ontario. Um, what they were able to build was, so they had, for indexing cones, tipped cones, it was a challenge that many teams struggled with. Cybercavs had a very unique level of autonomy to handle it. What they had was a vision camera that would look at the field, see the cone, figure out its orientation, and then aim their claw and clamp at the exact right moment to pick it up and hold it. Even getting a robot to autonomously clamp a claw down correctly is really, really hard. There's a reason that people just always say use rolly grabbers, unless apparently you're Cybercavs, and then you can just not and still do incredibly well.
Yeah, I think vision tracking of game pieces has been one of the most interesting autonomous things in the teleoperated mode recently. We saw so many teams this year using vision tracking to identify notes and where they were in the autonomous period and in the teleoperated period. 4481 with their Open Alliance build thread, Team Rembrandts, they're one of the best examples of it. You can see through the season how they're holding up the notes up against their orange shirts, and their program is still identifying them as notes. Very, very cool. Just impressive implementation there. And really interesting to see how they're using it in autonomous, but they're also using it in teleop. And I think that's one of the most interesting progressions that we've seen recently in FRC. The autonomous period in the 2024 game saw some of the most complex routines in chess games that we've ever seen in this program, combining localization and game piece tracking with scouting and timing that first sprint to the middle. We also saw more and more teams turning to that autonomous pathing in the teleoperated period. With the introduction of April tags around the field for vision tracking in 2023, fully autonomous cycles are becoming a reality for many teams. Teams like 3015 and 6328 are publicly pioneering this effort, with 6328 starting to do pre-programmed cycles as early as 2023. How do you see auto evolving for teams?
One way I think I could see it evolving is, particularly as we see the vision technologies get better and better, seeing more and more teams adopt some sort of autonomous game piece tracking, be it during the autonomous period or even during teleop. If more teams say get to a point where they can get close to a note, then tell the robot, hey, we're near one, go grab it, and then have it do it. I realize that's probably complicated now, but I wouldn't be surprised if, a few years, maybe even 10 years to give it a longer goal down the road, we could see some things such as that develop.
Yeah, that would be interesting. I think something else that FRC could potentially look at is that auto in FTC is 30 seconds long. And I know that that's somewhat to do with the slower robot speed, but could we see that happening in FRC?
I think maybe, but you would need some changes to the format autonomous currently takes, mainly because I'm not sure if there are enough tasks on the field to keep 3 FRC robots busy for 30 seconds. FTC robots, Ari, you brought it up, but as a proportion of their size and as a proportion of the field size, they travel much slower. FRC robots at this point do travel quite quickly unless they start putting like speed limits to prevent carpet damage, which I'm not saying they will, but I'm also not saying they won't. But yeah, FTC robots with that 30 seconds, they still have lots to get done, but they also have more space to traverse that they can't traverse as quickly. So I guess to round up my rather long-winded answer, maybe, but with changes.
Yeah, I think that as the playing field of mechanical design gets more equal and we start having more suppliers that provide things to the floor of FRC, software will become sort of this great differentiator. It already is to an extent. And I think that as we get higher and higher with controls and the availability of different systems, we're going to see some really interesting autonomous modes. One thing in controls that I think would be really interesting in is that VexU has a minute of auto, and there have been some really cool innovations there, like the use of LiDAR, and now that we have our April tag tracking, I think it would be cool if we really got to the next level of controls and started using things like that.
Yeah, absolutely. And I do think we might be starting to approach that as we have some teams who are being finding an ability to write full field cycles, such as, mechanical. I mean, we've already brought them up, but Mechanical Advantage out of New England and Ranger Robotics out of New York, already doing that. Obviously, they are two teams out of the 3,000 something, pushing closer to 4,000 teams that exist. But if two teams can do it, that does indicate that more teams could start looking at it in the future. So especially if we see sensors expand, like, for example, I'm not sure if LiDAR is really a thing in FRC at all at this point. But if we do see more and more sensing abilities, I could see more and more teams adopting higher and higher levels of autonomy.
Autonomous mode pushes the boundaries of programming in FRC year to year, and will continue to as the field of robotics and control continues to grow. From humble move forward autos in 2003 to the global positioning and game piece tracking we saw 2 decades later, we can only imagine where these 15 seconds will take us next season and beyond. Until then, thank you for watching, and thanks to Nick for the rewind. Make sure you subscribe to Fun's YouTube channel. If you enjoyed the show, give it a like and let us know in the comments your favorite autos or any other topics you want to see covered. Next time on Rewind.
This video on Fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply.